Okay, so right now we're going to do HCF and LCM. So these are usually the commonly tested questions. So first thing first is, let's do a recall. Do you all remember last lesson we learned HCF, right? What is the strategy for HCF?
The strategy for HCF.
What's the strategy of HCF that we learned?
We learned that HCF is always the lowest power and the
Okay,
most
wait,
common term.
I'll write down. Lowest power.
Common terms.
Okay.
Okay.
Common terms.
Yeah.
Okay, so later I will go to do the HCF. So now we're going to do LCM.
Okay.
So can you see LCM right here? What is the strategy for LCM? Let's do another recall.
Highest power term, and it's every single term.
Okay, so highest power. So you can write all this down in your notes also. Okay, not just highest power, but must all be the
everything.
Everything means like literally every term.
Like literally any term you can plug.
Okay, so right now, remember I was telling you that to do this strategy, you must make sure that all your numbers are in index notation. Then you can use this strategy, right? So can you see that here is this is number 1 and this is the second number, the first number and the second number. So I call this as number 1. I'll just put #1. So this is first number, 3 to the power of 5 times 7 to the power of 6 times 11, right? So 3 to the power of 5 times 7 to the power of 6 times 11, I do not want you all to put this in a calculator because why? It already satisfies the condition that it is in index notation. Agree? So you can write in your notes that this is #1 and this is #2. So right now, can you look at number 2 means the second number. Do you realize it doesn't fulfill the condition because it's not in index notation? So right now, I want you guys to pause the video and try to make this into an index notation. After I double check your answer with mine. Okay, so I hope that you guys have gotten the answer. So for number 2 is, the number is 160083, right? If you break it down into index notation, your answer should be 3 to the power of 3 times 7 to the power of 2 times 11 to the power of 2. So now, let's say in exam, let's say you panic and you want to see whether your answer is correct. What do? Can you see all this here?
Key in calculator.
Yes, literally key all this in a calculator and see whether does it also give you 160,083. Okay, if it does, then yes. If it doesn't, then die. You need to redo. Okay, those. So right now, this is number 1 and number 2, right? So let's go and do the HCF and LCM. So can you see I color code HCF to be the one in red? So how do we find the HCF? Remember I told you it must be the lowest power.
Yeah.
So let's look at here. Not just lowest power, but it must be common term. So can you see the first one is 3 to the power of 5? And we have 3 to the power of 3, right? So are they common? They all have the base of 3, right or not? But we only take the
common term.
Not just common term. We take
the
lowest
lowest
power. So what's the lowest power?
3 to the power of 3.
Yes, so the first one will be 3 to the power of 3. Next, followed by 7 to the power of 2 because that is common, not just common, but also the lowest power. Then the last one, you can see 11 and 11 square, right? So which one shall we take?
11.
Because 11 is the lowest power and that's the answer. Now, if you put this in the calculator, you are wrong. Why? Can you see the question right here? They say that they give your answer as a product of prime factors in index notation. So you do not need to put these numbers in the calculator. You just stop right here. Clear so far? Next, let's do LCM. So now for LCM, you must take the highest power in every term, right? So what is the highest power? So let's start with 3 to the power of 5 and 3 to the power of 3. So if we take the highest power, it should be
3 to the power of 5.
3 to the power of 5. Next up, let's do the base of 7. This is 7 to the power of 6 and this is 7 to the power of 2. So which is the higher one?
7 to the power of 6.
Yes, 7 to the power of 6. And the last one is 11 and 11 square. The highest power is?
11 square.
Yes, and the end.
Yes.
That's all. So that's all for type 1. Very easy. That's why it's type 1. Okay, those. Can I move on?
Yeah.
Okay. Make sure you all always color code, okay? Can you see I use red with red with red? Green, green, green. Blue, blue, blue. Okay, so next time when you revise, it's a lot easier also. Your eyes will just follow to where the same colors are. Okay, so right now, let's go. So now for type 2. Now, this is actually a working backwards question, so I'll not do that yet until you guys understand the concept. So I'm going to move on first. I'm going to do type 3 later, or type 2 later. So right now, let's do type 3. Now, type 3 is actually a very interesting question because they want the smallest integer. Smallest integer means the number needs to be as small as possible. And when they say integer, they are referring to n. So take your highlighter right now and highlight this. 3675n is a perfect square. So I would call this question as a prediction question type. Okay, so what do I mean by a prediction question type? So you can see pink with pink. I'm going to try make all these words. Can you see all these are words? And I'm going to translate all these words into numbers. So basically here is 3675n. I just put as 3675. If they don't write any sign, what's in between 3675 and n? What sign is it? 3675 times n, yes. Next, can you see the word is? Is what symbol? What symbol represented? Yes, equal. So use is as equal. Now, can you see perfect square? So I'll just write down as perfect square first. So now, what is the background knowledge of perfect square? So basically, right, you need to understand that perfect square means that the power is a multiple of 2. Okay? And this part right here is where your prediction is going to be. So-called like prediction. That's not the right term for it, but it's like so-called your prediction. Okay? So right now, first thing first is whenever you do this, you must always make sure that this is being broken down into index notation. Because right now, this is not in index notation. So let's go and do it in index notation. Pause the video. Okay, see whether you can get the same answer as me. I hope that you guys get the same answer as me. There's 3 times 5 to the power of 2 times 7 to the power of 2 is your 3675. So can you see times n? So I just follow times n. Okay. So guys, let me ask you, when they don't put any power here, by default, what number is it?
1.
Very good. So by default is a 1 if they don't put anything. Next, you need to know is, can you see here? This is times n. Times n means, will your prediction be bigger or smaller than the one in red? Times means what? Will it get bigger or will it get smaller?
Bigger.
Yes, because of this multiplying effect, means this answer will be bigger. Because it's multiplied. Understand? So now, guys, there's only 2 things it can do. Meaning this prediction part, there's only either stay. Why stay? Stay because it meets the condition that it is a multiple of 2. Either it stays or go up because it needs to get bigger. Clear so far? So now let's look at the first one. Can you see this person is 3 to the power 1? So this 3 to the power 1, does it meet the condition that is a multiple of 2? Is the power a multiple of 2? Yes or no? Is the power a multiple of 2? What's the power? The power is what number?
3 to the power 1.
So is 1 a multiple of 2? No, right? So can it stay or not?
No.
So therefore it needs to?
Go up.
So what's the closest it can go up such that it becomes a multiple of 2?
4.
Yes, 2. So it becomes 3 to the power of 2. Next, let's look at the next one. Can you see the next one is 5 squared, right? So 5 squared, does it meet the condition that the power is a multiple of 2 already? Yes or no? 5 squared, yes, right? It meets the condition that the power is a multiple of 2. So will it stay or will it go up? Stay. You don't need to go and change it already. Last one. Can you see here? This is 7 to the power of 2. So 7 to the power of 2, does it meet the condition that the power is a multiple of 2?
Yes.
Yes or no?
Yes.
Yes, right? So does it stay or do you need to make it go up?
It stays.
Yes, so stay as 7 to the power of 2. So now how do you find n? So this is like algebra already. So therefore, you know something times n will give you this person, right? So that means that n will just take 3 squared times 5 squared times 7 squared and divide by your 3 times 5 squared times 7 squared. So when you divide all this, your answer will be 3. Because why? 5 squared can cancel out 5 squared, 7 squared can cancel out 7 squared, and 3 squared divided by 3 is just 3. And that's it for type 3. So since now we are on type 3, the next kind of question that I want to do will be type 5. Okay, so we'll move on to type 5. Okay, so why do I want to do type 5? Because, right, just now, do you remember we saw the word called perfect square? So now the keyword is perfect cube. So same thing, I'm going to use the same highlighter in pink. This, the moment you see this, like 525k is a cube number, or sometimes they will say perfect cube. It means that this is a prediction question type. So this prediction question type, can you see this is 525k? So let's write 525. K means what? They don't write any sign. So it's 525 times k is what symbol? Equal to a cube number. So I just write as perfect cube. So what does perfect cube means?
Divided by 3.
Be more specific. So just now, perfect square is?
The power is a multiple of 3.
Power is a multiple of 3. So right now, perfect cube means the power is a multiple of 3. Perfect square means the power is a multiple of 2, right? So perfect cube means that the power is a multiple of 3. Okay. So right now, same thing. What do we first have to do? You all remember. What do we first have to do?
Index notation.
Okay, index notation for which number?
5 to 5.
All right. So right now, I want you guys to pause the video and index notation. Okay, pause the video and make this into index notation and see whether you get the same answer as me. Okay, so hopefully you guys get the same thing as me. So this is 525. So 525 is actually 3 times 5 squared times 7 times k will give me a perfect cube. So guys, let's start predicting what is the perfect cube. So when they don't write anything, it's always 3 to the power of what? 1. They don't write anything, it's 7 to the power of 1, right? So can you see here? It's a multiply by k. So multiply by k means your answer must be getting bigger or getting smaller. Must be bigger. So there's only 2 things your power can be. It's either stay
or go up.
Stay if it satisfies this condition right here, that is a multiple of 3, or it will go up. Okay, later there's a scenario where it will go down. So right now, I just want you to understand one concept first, that is the going up. Okay, so let's look at the first one. Can you see here? It's 3 to the power of 1. Does it satisfy as a multiple of 3? Yes or no?
No.
No. So it should be a 3 to the power of what?
2.
2 will not give you a multiple of 3. It's cube.
3 to the power of 3.
Yes. So next up, can you see here 5 square? 5 square, the power, is it a multiple of 3? No, right? It is actually
5 to the power of 2.
So what should be the correct answer? It should be 5 cubed. Yes. So next up, we have 7 to the power of 1. Also doesn't satisfy the condition. So it should be 7 to the power of 3. So hence, how do we find k? Do you realize it's the same boring question? Right? So next up, to find k is, you take 3 to the power of 3 times 5 to the power of 3 times 7 to the power of 3 and divided it by 3 to the power of 1 times 5 to the power of 2 times 7. Put it in the calculator and what do you get? You should get a 4-digit number. Yep. So you get 2205. That's the answer. The end. So hopefully, I hope that you all copied literally everything you see on the screen and also color coded, yeah? Okay, fun part. The last prediction question type. Okay, so prediction question type, take note, there's only like different variation. So how your teacher can test you? There's only 4 variations. Let me do a recap. So what are the 4 different variations? So just now we learned what? Either it is a perfect cube. Let's start a perfect square first. So it's either a perfect square or a perfect cube. And then just now when we do perfect square or perfect cube, it's getting bigger. It's a times, right? So right now we will do divide. So what are the different combinations your teacher can give you? Your teacher can give you times and perfect square, times and perfect cube, or divide and perfect cube, and divide and perfect square. So these are the 4 different variations your teacher can test you. Got it? So just now, I already do 2 different variations with you, times and perfect square and times and perfect cube. So the next variation that I'm going to go through with you is actually divide and perfect cube. Because once you know how to do divide and perfect cube, you can apply the same concept to divide and perfect square. Got it? Okay, so the last type of prediction question type. So once you master all these different types, right, you definitely do very well in this topic. Yeah. Okay, so what is the next type? How come I know it's divide? Because can you see literally there's a divide sign here? So when a divide sign here, you just leave it as a fraction. Okay, so let's highlight the same thing as what we highlighted just now. So I highlighted in pink. This is the biggest giveaway to tell you that it's a prediction question type. But this prediction question type is actually a divide. Oh, just now I didn't write times, right? So can you all just now the earlier on run the prediction question type for type 5 and type 3? Beside the prediction, can you write multiply? Prediction and a multiply for type 3 and type 5. Okay? Type 3 and type 5, write a multiply beside the prediction. For type 6, this is a prediction and it's a divide. Okay, so now let's literally write here. Can you see here is 1400 over k is, it means equal, and I write perfect cube. So the same concept, I know that perfect cube means that my power is a multiple of 3. And now I want you to take a highlighter and write that down, this divide thingy, okay? This is a divide sign. So divide sign means it will affect your answer, means your prediction can either go 2 ways. It will either stay because it meets a condition that the power is a multiple of 3, right? Or what can it be? Because it's divide. Divide means getting bigger or getting smaller? Smaller. So it will go up or go down?
Go down.
Yes, it will get smaller, go down. Now, this is the part that a lot of students always get confused. Now, can you tell me what are the multiples of 3 that you all know offhand? 9, 12, and yada yada, right?
15.
So some students, right, if let's say the power is 3 to the power 2, then they say, can I go down already? This is the lowest because here is 3. So do you think it can go any lower? Let me ask you, how do you go from 3 to 6?
Times 2.
Then 6 to 9 also times 2. So how do you go from 3 to 6?
6 divided by 3.
3 to 6, 6 to 9, 9 to 12. How do you go from 3 to 6, 6 to 9, and 9 to 12? Yes, add 3, add 3, add 3, right? So why do I ask you this concept? Because how do I go from 9, 12 to 9? 9 to 6, 6 to 3. So from 3, how do I get even smaller? And what does it give you?
0.
Exactly. So the smallest number it can go is 0. Clear so far? So once you understand this concept, it's going to be very simple. So now, can you see this is 1400? For this question, you are in luck. Do you know why? Because they already give you the answer. You don't need to do it. So I'll just literally copy paste. 2 cubed times 5 square times 7 over an unknown number that I do not know is equal to a perfect cube. So let's look at this one here. 2 to the power 3. Does it meet the condition that the power is a multiple of 3? Yes or no? Yes. So will it stay or will you need to make it go down? Stay. So it just stays 2 to the power 3. Next, can you see this 5 squared? Does it meet the condition that's about multiple of 3?
No.
No. So it will stay or go down?
Go down.
Go down to what?
0.
5 to the power? 5 to the power?
1. 0.
Here, this concept here. No, 0. 5 to the power 0. Because the smallest it can go is 0. Next, what about the next one? We have 7. 7, we don't write anything, means 7 to the power of 1. So you want to make your perfect cube. Is it? Does it satisfy? It doesn't, right? So it should be 7 to the power of 0. So therefore, how do you find k? Very simple. No, you just swap these two positions. So therefore, you want to find k is just equal to 2 to the power of 3 times 5 squared times 7 to the power of 1 divide by 2 to the power of 3 times 5 to the power of 0 times 7 to the power of 0. And what answer do you get? So this is like algebra, just swap position. And that's all. Okay? And that's all for prediction. We just did prediction, perfect square, perfect cube, multiply, and divide. That's all. So now we have 2 more different question types. So what are the 2 more question types? It's number 4 and 7 is the same. Okay, so right now I want you to go to your notes. Find type 4. Then I want you all to write down same as type 7. Similar to type 7. Then can you also go to type 7 and write it down? Similar to type 4. But just that type 7 is a lot more difficult. Yeah. Okay, so now why do I ask you to write that? And what is this type 4 about? So type 4 is the last part before we go on to do working backwards. Working backwards is the most difficult one. Okay, so what is this type 4? So type 4 is this kind of question type. It's called a LCM question type. Now, why do I say it's an LCM? Because can you see this keyword called multiple? So if you see this keyword called multiple, the trick is take your red pen, circle the 63 and circle the 49 and write that down. The step 1 you need to do is to find, because they will tell you multiple, right? So multiple means, is it LCM or HCF? Which one do you think it makes sense? LCM or HCF? You see the word multiple. Yes. You see the word multiple means obviously you know it's an LCM question. Means you need to find the LCM of 63 and 49. Okay, so before you find the LCM, we need to go and do the breakdown of 63 and 49, right? So guys, what is the index notation of 63 and what's the index notation of 49? Anybody can give it to me. Index notation of 63. Three to the power 2 times 7. Yep. What about the LCM of, not LCM, the index notation of 49? Yep. Hence, from here, what can I say? What is the LCM of 63 and 49?
The LCM is 3 to the power 2 times 7 to the power 2.
Yes, 3 to the power 2 times 7 to the power 2.
That gives you 441.
No, we always leave index
Oh, wait.
notation.
Index notation.
Okay? Then let's see. Now, I know this is the LCM already, right?
Okay.
So it means that this number right here, 63n, is actually equivalent to this number here. So step 2, what do you just need to do is you take 3 square times 7 square and you divided it by 63. Now, how do I even come about this concept? It means that from here, you know that 63n is actually equal to 3 square times 7 square. Got it so far? So hence you want to find n, right? Because the question asks you to find n. So it's just basically algebra. Means you got to take 3 square times 7 square and divided it by n will give you your answer. Understand? So hence, what is the value or what's the answer for n?
7.
Yep. Yeah. And that is for type 4.
Okay.
Okay, so this we look at question number 4 and number 7, type 4 and type 7. It's also the same thing. Can you see yada yada is a multiple of yada yada? So yada yada is a multiple of yada yada. Same thing, right? Can you realize the format is the same? But now we have a problem. Can you see that it's 3 to the power of, they don't give you? Times 5 to the power of, they don't give you? Times 7 to the power of 3 is a multiple of 21. But if you actually follow the steps just now, you know that if you see this question, means it's a HCF or LCM question.
LCM.
Yes, it's an LCM question. So basically, what does that mean? It means that the first step you need to do is to find the LCM of this and this. Correct or not? So because that one is an unknown, I cannot find. But 21 I can find because what is the LCM of what is the index notation of 21?
Three times 7.
Yes. So 3 times 7 means it's actually 3 to the power of what?
3 to the power of 1.
Times 7 to the
7 to the power
power?
of 1.
Okay, so this is a little bit of hybrid of LCM and also working backwards. So now you need to find the LCM of both numbers, right? And you know that the LCM of both numbers I cannot find. You know why or not? Because can you see that here I don't know what is my X value?
It gives you
But
yada.
what is the concept of LCM that we recall? The strategy of LCM.
It is the highest power term and it's every single term.
Number 1, we know that we take the highest power. And number 2, it's not just the highest power, it must be like literally every term, right? So you can see we have 7 to the power of 3 well taken care of already, correct or not? Yeah, 7 to the power of 3. And then we have 7 to the power of 1 also. So when these two comes together, we must take the highest power, correct? So what's the highest power? 7 to the power of 3. Okay. Now next, can you see here is 5 to the power of something? Now here, is there any 5 to the power of something or not?
No.
So when you don't have 5 to the power of something, it will just be 5 to the power of what?
No.
5 to the power is still 5. Means it exists, but it doesn't exist. So it's 5 to the power of 0. But of course, we don't write that. Okay? So can you imagine, can you see over here, what does the question want? Look here, this one requires a little bit of thinking. They want the smallest integer of x and y, right? So what do you think x5y can be? Imagine if I tell you the smallest. So what do you think your LCM can be? I know for sure that over here, my LCM definitely has a 7 to the power of 3. Agree, guys? 7 to the power of 3 definitely exists. We need 5 to the power of something that exists also, and we need a 3 to the power of something that exists also, correct? So what do you think? Y value can be, they want the smallest. What can the smallest be then? 5 to the power of what? What can it be? Yes, it's 5 to the power of 0. Do you all know why?
Because you want the smallest.
Smallest. And can you see over here, don't even have 5 at all? So, because it's an integer, this person can actually be 0. It means that maybe y didn't even exist. So it's 5 to the power of 0. Means there's no 5 term. It's just 5 to the power of 0. Now, the last one is, can you see 3x? So right now, the last one is this 3x right here. And this 3 to the power of 1 right here. So remember, I told you, it needs to be highest power and every term, right? So can you see that this person already exists? Just now that 5 didn't exist, correct or not? That's why there was a potential that it can be a 0 because there is no 5 term here. But can you see this person already have a 3 to the power of 1? So the lowest x can be will be what? Yes, 1. So the lowest x can be is 1. So therefore, my answer will be x will be equal to 1 and y is equal to 0. So this question is not easy. It really requires a little bit of thinking and understanding of the concept. Got it so far? So the next part we're going to move on is working backwards, and that will be the other video. The end. See you.